Good afternoon, everyone. I am Neil Levin, CEO of VR Training. Since mid-March, we've been working with the Marine Corps PEO Land Systems Office, specifically the Advanced Assault Program, or PMAAA, to design and develop an entirely portable driver training system for the drivers of the new amphibious combat vehicle. The ACV weighs 35 tons, does 65 miles an hour on land and 11 miles an hour per water. There's many things that are interesting about this rapid prototyping effort. And before we go any further, I'd like to tell you about the teaming approach that we took for this challenge. There's 4 major companies involved in this project. My company, VR Training, is the prime. 302 Interactive is our lead software developer. We have Talon Simulation, who is our hardware engineer lead, and we have Theory Studios as our lead creative team. The approach is unique in that my company serves as a general contractor and product owner, directly managing the relationship between the clients and ensuring that their voice guides this product. While Talon has been my partner before, last year we built a mixed reality B-52 simulator for Strikeworks. Most of the other companies are not familiar with DoD work. They're primarily game and entertainment companies. The individual companies are flexible in bringing on developers for project work, developers that face a wide range of challenges on a regular basis. More than those devs that work for bigs or large smalls, if we need specific tech, we add it into the process. We've also achieved success by using next-gen tools, such as the Epic Unreal Engine 5, and prioritizing the fidelity of its software solutions. One last point is that we're very agile and affordable because of the flat nature of our business structure. You'll get to hear more from the individual companies in a minute. Before I go any further, I want to thank the PMAAA team, specifically their leader, Major Alex Purity. No OTA project has ever been run as efficiently and as perfectly as the OTA they put on this year. This is actually after our second limited user evaluation here in Orlando for the drivers. Having the subject matter experts of the drivers was integral to the success we found with this project. I mentioned before that this is an OTA. If you've been around for a couple years, you know about the increase in the use of the OTAs, or the other transaction authorities. These contracts are different than the FAR-based contracts. They're perfect for limited scope innovation projects such as ours, and ours was used to the fullest. The requirements that were established in advance for this OTA were broad enough that PMAAA was able to get a few different selections to choose from and different choices and approaches. This is amazing in that this project moved so rapidly. On March 15th, we first heard about it. And then 2 months later, we were under contract. Another 2 weeks later, we had already begun our production of the vehicle.
All right. I'm Brandon Nade, CEO and co-founder of Talon Simulations, the hardware engineering and integration manager of this project. We specialize in XR vehicle simulator solutions, and we have been at this for almost 10 years now, developing training and entertainment simulators. I'm going to tell you a little bit about what we engineered for this project. Now, the unique thing about the ACV being amphibious is that it has dual propellers and gear shifter transmission, as well as a steering wheel and pedals. So we needed to replicate those as accurately as possible because we'll be integrating that with a fully virtual environment. It needs to sync one-to-one in the real world as it does in the virtual world. So that actually involves some 3D scanning of the cockpit, and we were able to use that model and engineer from that to put a accurate location on 2 different configurations. So that was something we pitched to them, was having a desktop configuration, which can be deployed anywhere. The primary purpose of these is to be used on the ship at the point of need to reacclimate the drivers to the vehicle and the operation of it right before they get back in the seat and have to drive it. And that desktop configuration could also be adapted to a motion configuration with one of our compact 2 degree of freedom simulators. And each of those have their own Pelican case. So you would have configuration 1 you see up here on the top left. It's got a laptop, a virtual reality headset, steering wheel, a force feedback base, gas and brake pedal, and so all power from a laptop computer. in a rugged, customized foam that we designed for that specific case. And then the motion platform also broke down into its own case, as you saw in the video. And so that makes for easy transport, easy setup and breakdown times. They want to be able to use these anywhere in the world at any time. And we delivered 3 of each configuration to the field user evaluation, and we had 10 Marines each day evaluating each of those systems compared to 2 other team systems for a total of 50 users through there to get feedback and assess how they operated. And here is a little recap from that event. So those are all the systems in action. Everything held up really well. There's a few design changes we would want to make going forward with production. But overall, we're really impressed with the speed that we're able to prototype these things and develop a final prototype and deliverable for them in this time frame. I'm going to pass this off to our director for the creative side, David Andrade.
Good afternoon. Good afternoon. My name is David Andrade, and I was creatively and artistically directing this project. I was trying to make it really pretty. Let's take a moment to talk about that. Why should we spend time, resources, money, budget on making things look pretty? What we learned is that the Marines are training on incredibly old hardware. They're training on incredibly dated software. Some people are still using OpenGL in the 2020s, and that breaks my heart. Someone who's come from the film industry, I've worked on great movies like Life of Pi and shows like Man in the High Castle in Silicon Valley. I wanted to bring that creative touch that we have in the film industry to the ITSEC project. So here's a really cool thing. This is a simulation made in Houdini that shows how we could actually accurately visualize the look of waves as it's hitting an ACB out in open ocean. And to the left of that is a very confusing graph in Houdini that tells you how to do it. So if you zoom in, you got the secret sauce now, right? You can just do it yourselves. Reality is as though this process took months. The first 2-3 months were just testing everything that was available in Unreal 5.2. We have Water Body Ocean, Oceanology, Fluid Flux, Fluid Ninja, and other tools that are made for simulating water in video games. We had some really hard constraints though. It had to be replicatable. That is, multiple players have to be able to see it and interact with it. And frankly, it had to look really good on a small laptop running at least 70 frames per eye. It's a huge challenge. But we stepped up to the task and we made some pretty beautiful water. On the right here, you can see a few things. Here's a sandbar, and then using a fancy system of decals and some Niagara, we can make it look like water's coming up to the shore. Further out into the ocean, we used a combination of Water Body Ocean, Vertex animated textures, Niagara, and a lot of R&D to make it look really, really pretty. Again, why though? Because we want to establish something that feels real, that creatively grounds Marines. Let's take a pause here for a moment. Realistically, our customer is the US Marine Corps, but who are the people literally doing this? It's 18-year-olds who have played Call of Duty and don't have driver's licenses. And you can quote me on that because that's an actual thing that's occurring. A lot of these folks don't have driver's licenses. They're gamers, so they understand game terminology, game physics, game things. And we wanted to really lean on that visually and interactively. We mapped out terrain from Camp Pendleton. We grabbed a little area known as Warriors Cove. We measured the depth of the ocean to make sure we got it right. I pulled up a whole bunch of boating maps. I looked at tides to make sure visually everything was there. I don't have this slide, but there's actually an equation for how deep the ocean floor is relative to how fast the wave moves. And that's how deep we got, because we wanted to recreate visually and through software and physics and hardware engineering as if this was really an ACV. We didn't just focus on Camp Pendleton though. We also wanted to give the drivers another opportunity to play in what is effectively 29 palms. This is a fairly large map, but we condensed it. We looked at a lot of Unreal tools here, Nanite, World Partition. We used the updated landscaping tools. Because of our hardware constraints, we employed runtime textures, which if you don't know what that means, it basically means there's a lot of data and we're gonna swap it out while you're not looking. All of this allowed us to get incredibly high fidelity down to little bushes, all the way up to canyons and valleys. Here's a couple of screenshots. I just really want to show off the art team's hard work. It's an incredible thing. And the one cool thing about this whole project is that at the end of the final user evaluation, they had us, nerds, drive this vehicle. And we were able to drive this vehicle after going through training, reading the dialogue, reading all the manuals, and now we were able ourselves to do a small little course. So it's a testament to high quality, high fidelity virtual training. So with that, Bobby Torres.
Good afternoon, everyone. My name is Bobby Torres. I am a co-owner of 302 Interactive and the program director of training and simulation. Hard act to follow, David, Andre, Neil, and Brandon. But as they mentioned, I just wanted to talk a bit about what brought 302 Interactive and this team together and how the software engineering team kind of rapidly prototyped through the limited user evaluations through the 4.5 months of the development period of this project. 302 Interactive is not traditionally a modeling and simulation company. We were founded 11 years ago, building modeling and sim, but also for attractions and entertainment. So we've taken all of that consumer technology and gamification and entertainment side and brought that to the modeling and sim world. A lot of the decisions on design were driven by our experience in attractions and consumer entertainment. As David said, a lot of the operators of this vehicle are rather young, a generation even younger than myself. So they're used to playing Fortnite, Call of Duty, and basically being able to operate a vehicle that felt familiar to the games that they've been growing up playing wasn't an important experience. Also, the decision to choose VR to fully simulate the driving experience was also a challenging choice, but the right choice for the requirements. What we had to build was very portable and modular and had to be deployed to the fleet pretty much immediately. The prototypes that we delivered are actually being demoed right now, and they're kicking the tires on that, whether it's ready to go or not. I'd like to invite our lead designer, Justin Laguerre, to talk a little bit more about that process, taking in those user requirements and rapidly iterating in that 4.5 month process.
Hello, my name is Justin Laguerre. I was the lead designer on this project. If you've noticed, we've had a vibe that we've been constantly talking about during this presentation, and that is feel, right? When you are a young driver and you're driving this giant 2-story tall water tank, you have no idea what is going on around you, right? You have limited vision. It's a lot of stress, especially for young and new drivers. So the need for this simulator was something that related to feel, to really get them to experience driving. Some of these guys don't have driver's license. This vehicle is not easy to drive. There are a lot of components between the fact that you also have the ability to go into the water, you have stuff on land, you have the ramp to deploy, you have your trim vane in front of you. There's all these interactive components. So in the interior, we made every single switch work. Everything works for every situation, down to the crew heater, which turns on the heating inside the vehicle. Now, does that actually affect your driving? Probably not. But we wanted to give them that experience of everything working like the actual vehicle. So I want to talk a little bit about our approach, right? I said feel, and a lot of that, we had to interview a lot of these drivers. We talked to some of the instructors who trained some of these drivers as well. They talked about, okay, these priorities are what the students miss. These audio cues, the thunk as you hit that ocean floor, right? The beep of the horn, right? The fact that you need to beep it 3 times to make sure that everyone else knows around the vehicle that the ramp is coming down. Do not stand behind that ramp. It weighs a lot. This approach, by involving the Marines themselves, even in some of the design decisions, allowed us to give something that was catered directly to them, right? We combined our efforts as a software team, as an art team. You know, David mentioned the boot print, right? Down to those little details. Another one I'd like to bring up is they often might have an energy drink, right? We put a little energy drink in there. We want them to be immersed because that approach is what actually really delivered a simulated experience. And with that, I'd like to reinvite Neil back up to close us out.
Thank you, Justin. And thank you, the rest of the members of the team. This was an amazing project. It moved so quickly. It was crazy. One of the things, though, that was built into the project right from the very start was a number of interactions with the Marines so that we had the opportunity to spend time with them. 2 limited user evaluations occurred down in Orlando, where we had our simulators as they had progressed all through the time. And we had opportunities to speak with the drivers individually, collectively, to find out really what's going on, where we were good, where we were bad. And then as we got through the end of the process, we had our final user evaluations at Camp Pendleton. They were 6 days. We had about 60 different Marine drivers came through and experienced our simulator along with other simulators, and then got more feedback from the Marines. There's going to be 650 ACVs produced in the next few years by BAE. They've got about 250 of them already in operation. And training simulators like we've produced are essential to give the drivers of these vehicles the opportunity to fail safely. They can get out there, they can drive this at the schoolhouse and learn how to fail safely. Because right now, the only way that they train these drivers is by putting their butts in the ACV and letting them loose. This is not the real way to do it. So, as you can see, it's been a pretty successful program for us. Working with the Marines has been incredibly invaluable to everybody on the team to help get them out there safely. But a few more things about us as a group. It's an unusual structure, as I explained before. We have the ability to really add different technologies and technologists as we need them on a regular basis. We're highly flexible, highly affordable, and the work that comes out of our group is fantastic. But I'm going to leave this at this point. We look forward to hearing from you further. Are there any questions before we leave?
So I find it absolutely fascinating, the efficiency that you guys were able to go at with producing this in the time that you did. And I'm a little bit curious more about like the workflow that you guys followed and how you were able to work with all your different studios together on this to produce it in the time that you did.
How do you get a whole bunch of people together and have a ballet, right? We had to put on a show very quickly. We all had to be best friends. And thankfully, we are. We've all worked together for many years at the Orlando Game Space, now known as OMG Labs. So we've got a tight-knit crew there. And then from there, we just had to divvy up the work. It quickly became obvious. Bobby in 302, software and engineering, handle that scope. At Theory, we've handled all the visuals. We did some initial prototyping to get the ball rolling, but eventually we handed a lot of that off to engineering to focus on, while we focused on performance. And of course, Brandon with hardware and everybody at Talon, it was crucial to make sure all of those pieces work together. Ultimately, we had one dude who was glued to the chair for months and he couldn't get off. And that's really, the QA and iteration is the truth. That's how you get there.
Very different question.
Sure.
Did you all have any security concerns about using Unreal with the fact that China owns a stake in the company?
Yes, Tencent has a stake in Epic Games. And then, of course, we're using Unreal. Ultimately, no, it's open source. And we decided to copy that source. And while I've read it over the past 15 years, and I know pieces here and there, we compiled our own engine and we ran it our own way. So that never talked to the internet. We never sent any analytics or any of that data. Listen, I was on an email chain with the CTO of the Marine Corps, so we had to also protect that data as well and keep that under lock. Two-factor, making sure things were CUI. People had to go through CUI process. The best part, though, about Unreal is that being open source, we knew exactly what was coming and what was coming out of that. And all these laptops, none of them had to talk to the internet. They all had to be wired for their multiplayer experience. Unity, you had to pay a buttload to get into the source. So we found just using Unreal allowed us the full freedom to capture that. So no concerns, but it's a very valid one.
Vehicles now are software centric, right? There's a lot of software that lays underneath your interface and stuff. Did you stimulate alarms, interfaces, so that, touch screens and things like that as well?
Yeah, that's a great question. So just to recap it, like simulating large areas, right? Is that what?
Simulating the electronic interfaces.
Ah, right.
Touch screens, as well as the software that lays underneath those, so you get, engine failure.
Sure.
And
So you know how we locked some but glued someone to the chair? Well, we glued Justin to the manual.
Yeah, so I'm the guy who actually read all 1,000+ pages of the manual of what every switch does, and a lot of interviews with Captain Heron, who is an amazing resource, as well as other Marines, finding, oh, if I affect this switch, how does this switch get affected? How does that affect your bilge system? How does that affect this? When I hit the power switch, what turns off, what doesn't, right? It was quite a challenge. It was a lot of scripting. We built a plugin. We went with a plugin based approach to make that process go a little bit quicker. And ultimately, we weren't able to get every single switch in the vehicle, but everything related to the driver, we were able to accomplish. But it was tricky. There are multiple types of switches as well, especially in VR. When you have a switch that could have a lower, medium, and high setting, is the tracking good enough to allow you to select those individually? We came up with a creative approach that allowed you to basically treat it as a button. You would touch the switch and then have 3 options, change that. Same with the dials as well, allow you to scroll back and forth for like your brightness. It was a really challenging approach. It was actually something that I primarily worked on. You could say it was a lot of spaghetti in the middle of that too, trying to find every possible interaction, but it was a lot of fun. And ultimately, the switches as well, we went one step further with fidelity to even change all the different little sound components for each switch on how they activate, all the way to they have a switch inside that allows you to see if the other switches work. And we even got that one working. So it was a lot of fun. And I say fun, but also it was a lot of serious fun. But it was great. All right. Thank you all so much for coming. This has been a great talk. And please stop by booth 3301 and come talk to us. Thank you.